So I'll start with first the definition of lines and angles. And a line is a straight line that extends in both directions and has no end. So both directions and has no end. So you can think of it something like this, and the arrows represent that there is no end. Whereas if you see the term line segment, that means it's finite in length, and it's a segment of this line. So say from point A to B, that would be called a line segment, whereas this itself is the line L. So you will see terms like line segment AB. So they're referring from the line, straight line that you would draw from point A to point B. And angles just refer to an opening. So if you have, say, two straight lines that intersect, we refer to this as an angle. And one of the basic concepts is if you have two lines that intersect, two straight lines that intersect, we notice that these two angles are equal. And these are called vertical angles. Now, I do want to emphasize that on the GRE, you will not see this type of terminology, but they just expect you to know that this condition means if you have two lines that intersect, that these two angles are equal. They're both x degrees, and this is the point at which they are intersecting. So there's also a matter of notation when it comes to angles. If this is point A and this is B, we call angle AOB, its measure is x degrees. So whatever this is, let's say it's 50 degrees. And I'll go over the angle measures as well. We say angle AOB is 50 degrees. And the same figure, when you have these two lines intersecting, this angle is equal to that. If this is y, that's y as well. So the concept of angle is, what we say is that if we have, say, two lines that intersect with each other, and if all four of these angles are equal, we say that these two lines, L and M, are perpendicular. So it's sort of a definition. And we also define this entire measure to be 360 degrees. Now, keep in mind, this number is completely arbitrary. I think we just chose 360. Might have to do with the number of days in a year, but the number itself is arbitrary. One could have chosen 200 or any other number. And so here, when we say that two lines intersect and each of these angles are equal, and if we assign the measure of this entire angle 360, then the measure of each of those angles is 360 over 4, or 90 degrees. And we also use a symbol square to represent when two lines are perpendicular. So here we would say AB is perpendicular to CD. So this symbol, whenever you see this symbol, it denotes an angle of 90 degrees. So it's a matter of notation here. The next concept has to do with parallel lines that are being intersected by another line at an angle. So something like that. And what are parallel lines? Well, parallel lines are lines that do not intersect. So they're the same distance. So if we slide this line, it will never intersect. It will just merge and become one with that line. So I'm going to call this line L, line M, and say this is line K. Then what we observe is that if this angle is x, this angle is x as well. And the way you can visualize this is if you slide this line all the way and merge it, you'll find these two openings are equal. And then we observed earlier that this angle is same as x. So we notice that this angle and these two are equal. You'll see in geometry books they say alternate internal angles are equal in this scenario. But you don't have to know this type of a terminology, because on the GRE they're never going to say the alternate internal angle or something like that. They just expect you to be able to make these relationships. So there is no emphasis on terminology, and so you will never see a jargon, barring a few things like parallel, perpendicular. So here that's x, so this is x, and then the remaining angles, if this is y, then this angle is y, and we find that this is y, and that angle is y. So these are the key relationships between the different angles of two lines that are parallel and a third line intersected. So let's look at an actual problem. So you're given two lines are parallel, and then we have another line like this, and then another line comes at an angle. This is L, this is M, and you're given the L is parallel to M. So this symbol means lines are parallel. And they say P is perpendicular to M. So that's perpendicular symbol, which means this is 90 degrees. I'm going to call this P, call this N, and this angle is given to you as Y. This is given to you as X, and you have quantity A, quantity B, this is X, and this is Y minus 90. So when we have, just another concept I want to wrap up is we said that this entire angle is 360, and then if these two lines are perpendicular, then each angle is 90. But if you have a straight line, then this measure is just half of 360, so that's 180. So it doesn't matter if you have a straight line, you have another line coming in angle, these two add up to 180. So you may have to use that here. So there are two ways we can do this problem. One is direct algebra, which tends to be faster but harder to implement, or use numbers, and I'm going to do both. So here I have this angle is equal to X, and generally what I recommend with these types of problems is to label as many angles as you can, and then try to relate them to each other. For example, here I could say this angle is 90 because these are parallel, so that's 90, which means that this entire angle, which is X plus 90, is equal to Y. So the key with these types of problems is that it takes a little bit of a trial and error to see the relationship, so you should always start filling in all the information, and then somehow it will click. I mean, I went here, but then I didn't go further. There's another way we can do this problem, and which will be related to triangles, is this would be 180 minus Y. And I'll go over this next, that the internal angles of a triangle always add up to 180. So if we apply that property, we'll get the same relationship. So here we can rewrite X as Y minus 90. So this is Y minus 90, which means these two quantities are equal. So that's one way to do it. The other approach is to pick values. So I could pick, say, Y is 130. That tends to be a little bit easier, but you have to make sure that you pick strange enough numbers that they don't accidentally become equal. So if this is Y is 130, then we would say, okay, this is 130. And then we would say that's 90, which means X is 40. So what you then do is you replace those values here, X is 40, and then you plug in Y here, 130 minus 90, and you get 40. So the only difference is you're not using algebra, you're using particular values. So, you should be open to trying them in both ways. If you're not very comfortable with algebra, then your only choice is to use numbers. So, okay. So next I want to go over the concept of the sum of internal angles of a triangle. So let's start with, say we have this triangle. I'm going to call this A, B, C, and I'm going to refer to these angles as angle C there, angle A, and this is angle B. And what I'm going to do is to draw a dashed line, L, and I'm choosing L to be parallel to BC. So if I extend this. Now what I want to do is to be able to identify this angle in this region, and if I extend this line, it's this line segment AC, I find this angle is same as C, because these two are parallel, and then this angle is same as C. And then if I do the same thing with B, this angle is B, and then this opposite angle here is B. So what I notice here is that these three angles, so if I were to redraw this, this is C, this is A, this is B. They all merge to form a straight line. And that's the quick proof for why the sum of the internal angles of a triangle always equal to 180. Or the general rule is that they merge to form a straight line, because remember 180 is arbitrary. So always remember sum of internal angles of a triangle, any triangle, sum of internal angles, and internal angles referring to these inside angles, internal angles of a triangle is equal to 180 degrees. So that's a property we'll be using a lot. So I mentioned internal angle. There's also the concept of external angle. So let's look at any triangle. So this triangle, I'm going to call this angle x, this angle is y, and I'm going to call this external angle z. So by external angle, I mean if you extend one of these sides, then this angle is z. And I want to relate this external angle to these two internal angles. Now this is a straight line, which means this is 180 minus z. And here, these three angles have to add up to 180 degrees. I can subtract 180, so it becomes x plus y minus z is 0. Add z to both sides, I get x plus y equal to 0. So essentially what this means, this relationship says that the external angle is equal to the sum of the opposite internal angles. Of the opposite internal angles of a triangle. So many times applying that relationship helps you to do the problems quickly. But even if you don't see that relationship, you can always do it in steps and always recognize that the internal angles of a triangle add up to 180. So either way, you need to be prepared to use that relationship. So here's a problem I'm going to give you that asks you to apply something similar. So this is given as w, this is given as x, and this is given as y. And you're given quantity A, so this is a comparison, is 360 degrees, and quantity B is w plus x plus y. So here we're going to apply the rule that if this is a straight line and this is w, this angle would be 180 minus w. And this angle would be 180 minus x, same thing, and this is 180 minus y. Which means that all these three internal angles have to add up to 180. So I'm going to add w, x, and y to both sides, and this side I'll have 180 plus 180 plus 180 equal to w plus x plus y plus 180. I can strike out one of the 180s. I have this adds up to 360. So 360 is equal to w plus x plus y. So this quantity is 360. They are both equal. So this type of a variation would be something that you would be tested on. Another variation with these triangles and angles type problems that come up is, here you're given this right triangle, and when I say right triangle, one of the angles is 90 degrees, and you're given this line, and you're given that this is x, and that's x, and this is y. And the question might say, what is y in terms of x? So what this type of question really means is, how is y related to x? What is the relationship? So we're going to do it two ways. Either algebraically or use numbers to then figure out which of the answer choices is the correct answer. So we'll start with the algebra here. So we know this is x, which means that this angle would be 180 minus 2x. I'm subtracting two of these because these three have to add up to 180. So that angle is 180 minus 2x, and then I add it to y, and then I add it to 90, and this has to equal to 180. And I need to now just isolate y, because they're asking for what is y in terms of x. So you subtract 180, I get y plus 90, and then this is minus 2x equal to 0. Add 2x to both sides, and then subtract 90, I get y equal to 2x minus 90. So that's the answer. So if you had answer choices for this problem, this is how it would look like, one of the answer choices. If you had to do it with numbers, what you would need to do is when you asked what is y in terms of x, you select a value. select a value for x. So I would say pick something strange. Don't pick something like 60. I mean, you can, but generally multiple answers might hold true. So you might say, I would pick something like, say, 50. So we know this is 50, this is 50. So that's 100, which means this angle is 80. And we know this is 90. So 90 plus 80 is 170, which means y is 10. So when x is 50, y needs to be 10. And then you would have to take this value for x and plug it in all the answer choices, and then compute and find the one that gives you y equal to 10. And in this case, 2 times 50 is 100. 100 minus 90 is indeed 10. So that is the correct answer. Of course, there are some downsides when you're using numbers. You have to test all the answer choices. If you pick something common number, then maybe 2 answer choices would be correct. Then you would need to pick another value. But those are some of the downsides. Okay, next up is quadrilaterals. So quadrilaterals are just any four-sided figure. And something like that's a quadrilateral. And the question is, what is the sum of the internal angles? So we saw in triangle is 180. We want to know what these angles add up to. So think about dividing this into 2 triangles. We know that this angle plus this angle plus this angle is 180. And we know this portion, that angle, and this portion of that angle is 180, which means that they collectively add up to 360 degrees. So any four-sided figure, the sum of the internal angles of a triangle are equal to, the sum of the internal angles of the quadrilateral is always equal to 360. So next is pentagon. So a pentagon is a 5-sided figure. And again, so the question here is, what's the least number of triangles, that we can divide into, that we can divide this figure into? And we can divide it here and then here. And 3 is the least. 3 is the least number of triangles. And we know this angle, that angle, that angle is 180. This is 180. And then that, and that is 180, which means that the sum of the internal angles of this pentagon is going to be 180 times 3, or 540. And we can extend this idea to a hexagon. A hexagon is a 6-sided figure. And it would look like something like this. And again, we think about what's the least number of triangles we can divide this into. And here we find 4. 1, 2, 3, 4. And again, each one of these triangles add up to 180. So the sum would be 180 times 4, or 720. So here I'm sort of showing you what the pattern is as the number of sides increase. How does the number of angles change? So if you look at the pattern, number of sides in a polygon, and polygon refers to just any figure with many sides, and sum of angles. So if there are 3, which is a triangle, the sum is 1 times 180. If we have 4, quadrilateral, we had 2 triangles. Pentagon, we had 3 triangles. And then hexagon, we had 4 times 180. And if we have n, we see how it's always 2 less. So the general is n minus 2 times 180. And this would be for an n-sided polygon. And so let's look at a problem on this concept. So you'll see this notion of a regular polygon. So when you see a term regular polygon, what it means is that all sides and all internal angles are equal. So a question could be, you have a regular octagon, that's 8 sides, and what is the measure of one of the internal angles. So I'm going to try to draw this octagon, a decent octagon. So it's the same as the stop sign. It's barely regular. Okay, all right. So we have 8 vertices referring to these corners, and 8 internal angles. And we need to know what is the measure of this. So we know that in general for n-sided polygon, the sum is n minus 2 times 180, where n refers to the number of sides. And here, n, I have 8. So it's going to be 8 minus 2 times 180, or 6 times 180. And I'm actually going to not multiply this. You'll see a reason. Now to find the measure of each of these angles, because it's regular, all of them are equal, and there are 8 angles, I just need to divide this by 8. And I'm going to reduce this 4, and then 2 and 90, and 2 goes into 90 45 times. So the answer is 45 times 3, and it's 135 degrees. So for a regular octagon, the sum of the measure of the internal angle is 135 degrees.